For years, it was considered impossible. Paralysis from spinal cord injuries was seen as permanent. Then, a team of Japanese scientists, led by Dr. Hideyuki Okano, achieved the unthinkable. They developed a revolutionary treatment using stem cells, allowing a paralyzed man to walk again. This breakthrough offers new hope for millions suffering from spinal cord injuries. The news of this medical marvel spread like wildfire. Could this be the answer to a problem that has plagued humanity for centuries? The scientific community was abuzz with excitement, and rightfully so. This wasn't just a small step, it was a giant leap for regenerative medicine. The patient, who had been paralyzed from the chest down for years, was the first to receive this groundbreaking treatment. His journey had been long and arduous, filled with countless challenges and moments of despair, but hope was on the horizon. He underwent a procedure where induced pluripotent stem, or iPS cells, were injected directly into the injured site of his spinal cord. This procedure was meticulously planned and executed by a team of dedicated scientists and medical professionals who had spent years researching and perfecting this technique. These iPS cells, a revolutionary type of stem cell, hold the remarkable ability to transform into any cell type in the body. This means they can potentially repair damaged tissues and organs, offering a new lease on life for patients with severe injuries. Weeks turned into months, and something incredible happened. The patient, who had once been told he would never walk again, began to notice subtle changes in his body. It started with a tingling sensation, a faint glimmer of hope that something was happening. The patient started to experience sensations in his legs. These sensations, though faint at first, were a sign that the treatment was working. It was a moment of triumph, a breakthrough that defied the odds. Then, slowly but surely, he began to regain movement. First a twitch, a small but significant sign of progress. The medical team watched in awe as the patient's muscles began to respond. Then a flicker of muscle control. Each day brought new milestones, each one a testament to the power of science and the resilience of the human spirit. With rigorous physiotherapy, he could stand. The road to recovery was long and demanding, but the patient was determined. He worked tirelessly with his physiotherapist, pushing his limits and celebrating every small victory. Take a few steps with assistance, and eventually, walk again. The sight of him taking those first steps was nothing short of miraculous. It was a moment that brought tears to the eyes of everyone who had been part of his journey. His story became a beacon of hope for countless others battling similar conditions. It showed that with perseverance, cutting-edge science, and unwavering support, even the most daunting challenges could be overcome. The patient's journey was far from over, but his progress was a testament to the incredible possibilities that lie ahead in the field of regenerative medicine. At the heart of this medical miracle are induced pluripotent stem cells, or iPS cells. These cells have revolutionized the field of regenerative medicine and have opened up new avenues for treating previously incurable diseases. These cells are truly remarkable. They possess the unique ability to transform into any type of cell in the human body, making them incredibly versatile and valuable for medical research and treatment. They are created by taking adult cells, like skin cells, and reprogramming them back into an embryonic-like state. This process involves introducing specific genes that reset the adult cells, giving them the potential to become any cell type. This means that iPS cells have the potential to develop into any cell type in the body, including nerve cells, muscle cells, and even heart cells. This ability is crucial for developing treatments for a variety of conditions, from neurodegenerative diseases to heart failure. The discovery of iPS cells, a revolutionary breakthrough, was awarded the Nobel Prize in Physiology or Medicine in 2012. This accolade highlighted the immense potential and significance of this scientific advancement. Their discovery opened up a world of possibilities for regenerative medicine. Researchers now had a powerful tool to study disease mechanisms, develop new drugs, and even create personalized treatments tailored to individual patients. Scientists now had a way to potentially grow any type of cell or tissue in the lab, paving the way for new treatments for a wide range of diseases and injuries. This includes the possibility of regenerating damaged tissues, creating lab-grown organs for transplantation, and developing new therapies for conditions like Parkinson's disease, diabetes, and spinal cord injuries. The process of reprogramming cells to become iPS cells involves intricate genetic manipulation. Scientists introduce specific factors that reset the adult cells, effectively turning back the clock and giving them the ability to differentiate into any cell type. Clinical trials are already underway to explore the potential of iPS cells in treating various conditions. Early results are promising, showing that these cells can be used to repair damaged tissues and restore function in patients with chronic diseases. The journey of iPS cells from a groundbreaking discovery to a cornerstone of modern medicine is a testament to the power of scientific innovation. As research continues, the potential applications of iPS cells are expanding, offering hope for a future where many currently untreatable conditions can be effectively managed or even cured. The process of creating iPS cells might sound like science fiction, but it's based on solid scientific principles. It involves turning back the clock on adult cells to revert them to a more primitive state. This is achieved by introducing specific genes into the adult cells, genes that are normally only active in embryonic stem cells. These genes act like a reset button, essentially erasing the cell's memory and allowing it to become pluripotent again. Once the cells are reprogrammed into iPS cells, they can then be coaxed into becoming the specific cell type needed for treatment, such as nerve cells for spinal cord injuries or heart muscle cells for heart disease. Section 5. The Clinical Trial, A New Hope. The clinical trial led by Dr. Okano's team was carefully designed to evaluate the safety and efficacy of using iPS cells to treat spinal cord injuries. This groundbreaking study aimed to push the boundaries of medical science and offer a glimmer of hope to those who had lost it. The meticulous planning and rigorous protocols ensured that every aspect of the trial was thoroughly examined. The trial involved a small number of patients with severe spinal cord injuries who had very limited chances of regaining mobility through conventional treatments. These patients had exhausted all other options and were willing to take part in this pioneering research. Their courage and determination were truly inspiring as they placed their trust in the potential of this new therapy. The patients received injections of iPS cells that had been specifically transformed into a type of nerve cell found in the spinal cord. These cells were carefully cultivated and prepared in the lab, ensuring they were ready to be introduced into the human body. The process of transforming these cells was complex and required a high level of precision and expertise. The hope was that these new nerve cells would integrate into the injured area and help to bridge the gap in the spinal cord, restoring communication between the brain and the body. This integration was crucial for the success of the treatment, as it would enable the patients to regain some level of function and mobility. The medical team remained cautiously optimistic, knowing that this trial could pave the way for future advancements in the field of regenerative medicine. Section 6. Groundbreaking Results, A Giant Leap Forward. The results of the clinical trial were nothing short of remarkable. The patient who received the treatment showed significant improvement in his motor function. He was able to stand, walk with assistance, and even regain some bladder and bowel control, functions often lost after spinal cord injuries. While the trial was conducted on a small scale, the results were incredibly encouraging. They provided the first real evidence that iPS cell therapy could potentially be used to treat spinal cord injuries in humans. The success of this trial has ignited a wave of optimism and spurred further research in the field. Section 7. Potential and Promise, A Future Without Paralysis. The implications of this breakthrough are far-reaching. If iPS cell therapy proves to be safe and effective in larger trials, it could revolutionize the way we treat spinal cord injuries. Millions of people worldwide who live with paralysis could have a chance to regain mobility and independence. Beyond spinal cord injuries, iPS cell therapy holds immense potential for treating a wide range of other debilitating conditions. Scientists are exploring its use in treating Parkinson's disease, Alzheimer's disease, heart disease, diabetes, and many more. The possibilities seem endless. Section 8. Challenges and Limitations, The Road Ahead. While the initial results are incredibly promising, it's important to remember that iPS cell therapy is still in its early stages. There are challenges and limitations that need to be addressed before it becomes a widely available treatment option. One of the main challenges is the risk of tumor formation. Because iPS cells have the ability to divide and multiply rapidly, there's a risk that they could potentially form tumors. Researchers are working on developing safer and more efficient ways to generate and deliver iPS cells to minimize this risk. Section 9. The Future of Regenerative Medicine, a New Era. Despite the challenges, the future of iPS cell therapy and regenerative medicine is bright. With continued research and development, we are on the cusp of a new era in medicine, an era where we can potentially repair or replace damaged tissues and organs, offering hope and healing to millions. The groundbreaking work of Dr. Okano and his team has opened up a world of possibilities. It's a testament to the power of scientific inquiry and human ingenuity, a reminder that even in the face of seemingly insurmountable challenges, there is always hope for a